are on practice test 2, and we are doing problem 4B. So we're going to multiply by 2. Anybody remember what the 2 is called? Scalar. Very good. You know that's going to be a vocab word on this test. So 2 times C. Answer is 2, 4, 6, negative 2, 2, 8. That's the one no one's missing, right? No one's going to miss that question. We're all going to get that one right. All right, can I multiply A times C? Is that going to be doable?
Yes.
A and C. Well, what are the dimensions of A? What are the dimensions of C?
2 by 3.
Oh boy, they can be multiplied, and I will end up with another 2 by 3, right? Remember, the inside dimensions have to match, and the outside ones are our answer, the size of our answer. All right, so here we go. When we multiply, it's rows times columns. So we're going to take the 1 and the 2 and multiply them times the 1 and the negative 1. So that gave me negative 1 if I added right. I multiply each pair and then add them up. Now, see that 1 and 2, I'm going to use it again because I need to use that row for all these spots. So I'm going to use that 1 and 2 for the middle column, and I'm going to use that 1 and 2 for the last column. So I'm taking top row times second column to find that number right there. So is that 4? And then top row times third column to get this spot, which is 11. Is that matching what you're doing?
Yes.
Max, you practicing with us?
Mm-hmm.
Okay. Now once I get the whole top row done, then I'm going to move to the bottom row.
Wait.
So now I'm going to use the 3 and the negative 4 over and over and over again because I have to use that row if I am in the bot. Yeah.
For the first one, I got negative 2.
For the very first number?
Yeah.
Okay, what's 1 times 1?
Oh, never mind. I got it. Sorry.
It's okay. So now I'm taking my second row times my first column. And check my arithmetic, I think I got 7. And then my second row times my second column, I got 2. And my second row times my third column, negative 7. Easy to make mistakes there if you're not careful, Max.
Isn't that first one supposed to be just 1 or negative 1? Because it's
What?
3 plus. Oh,
That's
no,
negative
never
2
mind,
plus
sorry.
1.
Yeah, I'm not
It's
picking up.
negative 2 plus 1.
Okay, do I have any mistakes up here? Okay, Jordan, you with us? Matching, everything matching?
I've read it.
Huh?
What?
Did you match me
Yeah,
when
I
you
got
did it?
that. Yeah.
Okay. All right, how about D?
No.
Can't do it. And we can't do it because A is 2 by 2 and B is 3 by 3. And when you're adding, they have to match. They don't. That's not possible. They have to be a perfect match. So they have to be a 5 by 7 and a 5 by 7, or a 10 by 10 and a 10 by 10. They have to match exactly if you're adding or subtracting. All right, what about E? Multiplying B times D.
No solution.
B is a 3 by 3,
And
but D is a 2 by 2. These don't match, so that is another can't do. No solution, impossible, empty set, however you want to indicate it. Now what about 2D minus A?
Yes.
So 2 times D, and be careful, make sure you're going in the order they tell you to. Okay, want to take 2 times D and then subtract A. Now, 2 times D, we can do that. 2 times D would be negative 4, 2, 6, 12. Is that good? Now we're going to subtract, right? So here we go. Negative 4 minus 1. All together now? Negative 4 minus 1? Negative 3?
Negative 5.
Negative 5. Negative 5. 2 minus 2. 6 minus 3. And 12 minus negative 4. Yep. The arithmetic's easy, just do it carefully, you should be fine. Okay, here we go. We have our 3 by 3 determinant. Magnus, I know you got up early this morning. Try to stay awake. Do you remember how to do this? Can you share your thoughts with us? What do we do first? How do we start?
4 and a half, right?
No. No. We are on problem 5.
So you take that first diagonal,
Yep.
starting with 2, going to 0.
Yep.
You multiply that together,
And I would get
you get 0.
0. And then I'll do the same thing here, and I'll get another 0. And then I'll go over here, and I'll get negative 4. So the total, I get 3 times, boom, boom, boom. And the total of all that is negative 4. So then, Mr. Kaufman, what do?
You do the opposite way.
I do the opposite way. So I start down here, there's another 0. There's a 10,
Negative 1.
and another 0. It's easy to do. You just got to remember when you're timesing by 0, if there's a 0 in there, it's going to be 0.
It's like 6 or what? Something else.
It's like 6 or something else, Max says. He's probably right. It's either 6 or something else. Actually, I think it's something else. Because what do I do with these two numbers? Subtract.
them.
So it's negative 4 minus 10, or negative 14.
I keep doing it wrong.
It is a shame to do all that stuff and then forget the very last step. The very last step is a subtraction. Negative 4 minus 10. Okay? And we have to do negative 4 minus 10. It doesn't work the other way. So we go these diagonals, minus these diagonals. Number 6A. What is A sub 1, 2?
4.
Yes, it's 4. Because what does sub 1, 2 mean? Row 1, column 2. Row 1, column 2. What are the dimensions of matrix A?
4 by 2.
4 by 2. That is a 4 by 2. How many of these does it have? 4. How many of these does it have? 2. In the expression 3A, 3 is called a scalar, and that's SCALAR. Is A square matrix?
No.
Why not?
Because it's 2 by 4.
Yeah, it's not it doesn't have the same number of rows as columns.
Yeah.
Can we just say it's like not a square? Like exact
It does
square?
not have the same number of rows as columns. Define a matrix.
Rectangular array of numbers arranged in
A rectangular array of numbers arranged in rows and columns. A rectangular array of numbers arranged in rows and columns. Oh, now we've got our big, the big problem.
Okay.
Alright, so let's see how we do here. Go ahead while I'm drawing all this and start filling in your chart if you can. Got the audio. Total.
Fixed intervals.
Uh-oh, it looks like we're minimizing this time, which there's no difference in a minimizing problem. It just means what? At the very end, when we plug in and we get all those values, instead of looking for the big one, we're going to look for the
Smaller
one. Yeah, that's no big deal.
Yay.
All right, so electronics, okay. It must make a minimum of 600 audio players and 800 phones, and a maximum of 1,500 audio players and 1,700 phones. So, if we let X be audio players and Y be phones, how many audio players do I have to make? The interval they give me is what? They say you have to make between,
615.
for audio players, it's between 600 and 1,500. So you can either write that, and I didn't make my boxes big enough, you can either write that like the inequality, which is what, I'm going to graph that, so I'll write it this way. Or, if you prefer, you can write that in your interval notation, because that's what it is, it's an interval. They're telling you right from the get-go that whatever X you come up with, it has to be between these two numbers. And then what are they telling you about the phones?
800 to
800.
Same thing, but its numbers are 800
to 1700.
and 1,700. So again, if you prefer the brackets, you can write it with the brackets. But we always graph our fixed intervals. If our problem has fixed intervals, and they don't all have that, but if they do, that gets graphed. And you remember from yesterday what that looks like when I graph those? What happens with those fixed intervals? Aren't they vertical bars? Don't you have a bar this way and then a bar this way? That's what's going to happen. All right, what else do I know? Do I know anything else? The cost for, okay, so the cost for audios is 55 and 95. At least 2,000 items must be produced. What does that mean?
Totals.
The total number has to be at least 2,000.
Okay.
Now wait a minute. That means that if I add X and Y together, has to be greater than or equal to 2,000? Would you agree? And then I want to minimize my cost, so I'm going to minimize 55x plus 95y. Now don't graph that. That's why I kind of list it separately, because I don't want you to get confused with anything to graph. This we save till the very end, remember? When we have our points, we plug into there. So, I guess, I think I've written everything down in my chart, so I'm ready to graph now. It's really not pertinent in this problem, but I certainly wouldn't mark it wrong. What are two that almost always we want to just include here? X is greater than 0 and y is greater than or equal to 0. That just happens. It's kind of covered here already, but if you don't include those, it certainly won't be wrong. You're never going to be wrong including those. All right. Well, let's see. I guess let's go ahead and graph. Let's go ahead and graph these fixed intervals first. What scale should I use, do you think? 100? I think 100 is a good choice. You might have to extend a little bit. That's okay, extend a little bit. So 600, those are x's. Seven, 8, 9, 10, 11, 12, 13, 14. Kids, you're not plotting. We're doing this top interval right here. The only letter involved is x. So you're going to put a dot at 600 on the x-axis and at 1500 on the x-axis. And then you're going to go straight up from those dots. And where will you shade?
In between.
In between. So you don't have to shade if you don't want. Just know this is where you're talking about now. You got to be between the red bars. All right. Now let's do the same thing with the y's. So the y's are between 800. Ooh, I want red. The y's are between 1, 2, 3, 4, 5, 6, 7, 800. 9, 10, 11, 12, 13, 14, 15, 16, 17. So this time I'm going to draw a line straight across this way. So can you see where I am shaded so far? Between the red, between the purple. Are we talking about a box right here? So now on top of all that, we're going to put this equation. Now notice this one has both letters. So we'll cover up x and get a y of 2000. And then we'll cover up y and get an x of 2000. And then we're going to connect those dots, right? Ooh, I'm going to rely on you a little bit because
Triangle.
does it come on top of this purple line? Does it cross or does it?
Makes it triangle.
Oh gosh.
So can we use like a graphing calculator to figure that
No,
out?
no, no, no. You just
Use a ruler.
use your ruler.
I ain't got a ruler.
Use a straight edge of some kind.
Use your graph.
Got it.
Yeah, use your graphing calculator as a ruler.
Yeah, you can use your
Fair.
graphing calculator as a ruler. I need to. My picture's not very good. I'm gonna put those things on a piece of graph paper.
I
So
know
that I'm
exactly
making
what
sure
I'm
connecting
doing.
you right. Because I can fudge it, with my graph.
I just need to know what on the graph. this part, but now it's fine.
What are you thinking? Are you getting, I mean, you guys are sitting there with graph paper.
It's triangle.
It's a triangle.
Is it just a triangle?
It's a triangle.
Yes, ma'am.
That's what I'm trying to figure out. So when you connected, it came down here like this,
Yes.
sort of?
Yes. There's no triangle.
So now wait a minute.
Triangle.
Be careful. I'm not sure it's a triangle. Because remember, where are we shading the blue?
Down.
No?
No, up.
It's up.
The shading of the blue, remember it was at least 2,000? So we're in the box. We're in the box, but we're above the blue.
Oh.
So our corners would be here, I think.
Cool.
Would you agree with that?
Zero.
Because we have to be inside this box, but above the blue line.
Okay. So it's
Okay, so here we go. Let's start finding those points. Some of them are super simple. This point right here, this top one right here, is so easy. We know X is 600 and Y is 1700. Easy. So is this one. We know X is 1500 and Y is 1700. So easy. This guy right here, so easy. 1500, 800. Now, these two are also easy, but they're not quite as easy. We know about this point that his X is 600. He's on the blue line. And we know that points on the blue line add up to 2,000. So if X is 600, then Y has to be 1,400. And over here, we can do the same thing. Only over here, we know the Y is 800. And if the Y is 800, then the X would have to be 1,200. Because if you're on the blue line, you add up to 2,000. So every point on the blue line has to add up to 2,000. All right, now what happens?
I'm gonna plug them in.
Now we have to take all 5 of those points and plug them into our cost equation. So I'm running out of room here, so let's see. What does, I'll just write it above. So I'll plug that in. What do I get when I put in 600, 1,700? I got, 194,500. And this 166,000. Some of you may be able to intuitively rule out some of these points. Well, I hope I I typed all that in right. If I typed it in right, then I'm ready for an answer. I am minimizing my cost. So it looks like this one's the minimum. Would you agree? So my answer is, I'll make, or he'll make, or someone whoever's making this will make, 1,200 audio players. And 800 phones. For a cost of 142,000.
Thank goodness we only have one of these. Else I'd die.
All right. Now let's do our last problem on the test. Keep in mind, this is the test. You've taken it. You just took the test. So now we have our calculator problem. I have to erase this. Is everybody okay with all this?
Yes.
Yeah.
All right. So now our calculator problem. By the way, all of the stuff we did here on your test, you're going to get points for. So even if you find these problems overwhelming and you think there is no way I'm going to be able to do this by myself, fill in whatever you can in the chart. Graph whatever you can. Whatever you can get done is going to be worth something. Whatever you do not leave this page blank. Ugh. That would be bad news. All right, so here we go. We have A, B, C, D. So 1, 1, 1, 1, 10. 2, -1, -1, -3, -15. 4, 2, -5, 0. 0. Somebody found out on your quiz that if you type in one number wrong, you're going to have trouble. So please make sure that you got the zeros in the right spot, negatives in the right spot. All right, so Caroline, here we go. We're going to type this in. So we're going to go second matrix and over to edit. Press enter. What are our dimensions?
4 by 5.
4 by 5, so 4 enter, 5 enter. Then we'll put in the numbers. And once we get all our numbers in, we'll second quit. So tell me when you're ready, Caroline. You got them all in.
Okay.
All right, so we go to second matrix, over to math. Click all the way down till you find RREF and press enter. Then second matrix, enter, enter. And it should pull up the new matrix for you. And talk about the rigged problem of the century. James?
The be one like where it'll be rigged to where we have zeros all on one
No,
line.
you're gonna have an answer. It isn't gonna be, you're not gonna get a weird case, you're gonna get an answer. Now, I'm not saying you're gonna get an answer that's as nice as 1, 2, 3, 4. So let's remember, what do we do if we hit enter and up comes this matrix and it's got all these crazy decimals here, then we just press the math button and enter, and it will change those into messy fractions, but they'll at least be fractions. Okay? Woo! Test 2 done. We are amazing human beings. Here we go. Now, since we've already been through this once, how about if we have 3 volunteers come up and somebody will do the substitution problem?
I'll use the Kramer's rule.
Okay. And then somebody will do our elimination problem. And we're gonna have to be organized and neat here, we're squeezing in.
Push Meryl out of the way.
And while the guys and girls, whoever's up here, while they're up here doing this, the rest of you, can you work down? So Jordan can,
I can just go to the other side of the board.
no you can't, it's not on video.
Oh, yeah, it's all on video.
You're on video, wave.
Oh, I just had a flex.
It's a lot of pressure, that's right. Okay, so there we go.
Okay.
Here you go, Max. Now, the rest of us are all busy working.
Wait, Mrs. Ford, am I doing elimination?
You are. And you're doing Kramer's rule.
Yep.
I just rolled one.
Max, we ask ourselves that question all the time.
I know, right?
What does Max think?
2x minus 3x.
What'd you get, Bo?
1, -1.
That's what I got. Good job.
You got 1, -2.
-1, -2. That's what I got too. Good work. Don't worry, Max. We're not. You have the longest one, so you just keep going.
All right.
So does anybody have a question about, Bo's problem? And we're gonna remember, it seems like a very picky little point, but we have to remember that we write our answer this way, right? So you get down here, you get x equals 1, you gotta put 1 comma, and then -1. Any question about that substitution problem? And then here, Jordan decided to multiply the top, or excuse me, the bottom row by -3. Looks great to me. Does anyone have an issue with the elimination problem? And Max has Kramer's rule.
Yeah, so I just took this, made this into a matrix, and then I remembered that the end products here will be used in the equation for x and y. X will go in here, cross multiply, you'll get -36. 36 and 13 will cross out. This matrix here, do the same thing, except we plug it for y, cross multiply, get -19. So the coordinates are 36, 13, and 19, 13. Boom.
Actually, shouldn't that, oh,
Yeah, because this is a negative, and we know we cross out the negatives, so that's why I didn't put any negatives, because I know they all cross out.
Okay.
Positive.
Okay, so let's go ahead and sit down and let's talk about this for a minute. You made a little bit of a mistake. You did a great job. It's a hard problem. You did a great job.
Okay.
So the first thing Max did was put down 2, 3, negative 1, 5. Everybody okay with that? His error happened here. When we do a determinant, guys, please pay attention. When we do a determinant, it's this minus this, not the other way around. It's always this direction minus this direction. So we get 10 minus negative 3, which is 13. You see what backwards? Yeah, so don't do that. And for the 3 by 3s, the bigger ones where we recopy the columns, it's the same thing. It's these minus these, always. So your denominator is actually positive 13. Now, when you did your X's here, you did the right thing, but it's 35 minus negative 1.
Okay.
So that should be 36. Now you did it backwards, so you got negative 36. It's 35 minus negative 1. And then this one will be 2 minus 21. This one you did perfectly, and it's negative 19. So there is the answer.
Okay, so I just had it backwards.
Yep. So just don't do it backwards again.
Alright.
All right, so we'll pick up there. Thank you, volunteers, by the way. That's wonderful.
Alright, that's not one thing.
Uh-huh.